So today we are going to be looking at more on the separation techniques that we have and how we use them to separate mixtures. So the first separation technique we are going to be looking at is distillation. So distillation, we use it to recover a solvent from a solution. The previous classes we talked about the meaning of solvents and the meaning of solution. So in some cases we also use distillation to separate miscible liquids. Those are liquids that can mix, not like kerosene and water. Kerosene will not mix with water. In fact, if you decide to mix kerosene with water, what you are going to discover is that the kerosene will just be on top and the water is going to be below. So you can't mix kerosene with water. But there are some liquids that can mix. There are some liquids that can mix, like let's say red oil and groundnut oil. So these two liquids can mix. So if you want to separate them, you can use distillation to separate them. So that's the case where we use distillation. So another thing is that the boiling point of those liquids must be different. They must be wide apart. So that means that they must all have the same boiling point. That's what they are trying to tell us. So now they said for distillation, you are going to heat the solution until the solvent vaporizes. So the solvent, which is what we need actually, what we are concerned with. In the previous ones, a good example like crystallization, we are concerned about the solutes. We are concerned about the solutes in crystallization. But here, we are concerned about the solvent and not the solute. So we heat it till it vaporizes. That means it turns to vapor. Then we condense that vapor to give us the solvent. So a good illustration is if you have something like this, then we have like a pipe. So we have this, then we have this. So this is a good example of distillation. So the mixture is going to be put here. So they will heat it, it will turn to vapor and escape through this particular part. So the other part that is here, let's say we have a mixture containing A, which is a solute, and B, which is a solvent. So let's say the boiling point of this solute, let's say the boiling point is maybe 30 degrees Celsius and the boiling point of our solvent is 20 degrees Celsius. So they will now heat this to a temperature of this 20 degrees Celsius. So you know that they have not reached the temperature of A, so that means that A will remain inside this container, but they have reached the temperature of B, which is our solvent. So what will happen? B will now vaporize, it will turn to vapor and escape through this particular point. So that then what they are going to do is they are going to put like ice. They put ice around this particular part so that anything that enter here, they are putting ice. So anything that enter here, instead of being hot, it will become cold. So when it becomes cold, it will turn back to liquid, and that is what we call condensation. So condensation is when you change something from the gaseous state back to the liquid state. So it's the opposite of evaporation or vaporization. So vaporization means that you are going from liquid to gas or to vapor. But when you are going from vapor back to liquid, we call it what? Condensation. So that's the main reason why they are putting ice here, so that it's going to reduce the temperature and it can change back to liquid. Then it will now enter here and come out here. So that solvent that now comes out that we have gotten here, we call it the distillate. So that is how we carry out the process of what? Distillation. Now what about what you are now, when we are now having many liquids that are mixed together, how can you separate them? Then that's going to give us what we call what? Fractional distillation. So just like when we were talking about crystallization, that you can have crystallization when a solute, when you need just a solute from a solvent, then when you have many solutes that you want to get, you call it what? Fractional crystallization. So the same thing with this. So when you're having many miscible liquids, you are going to be using fractional distillation. So we are going to boil them. Then the same thing here, the boiling point must have at least a 10-degree difference. Then we are going to boil them. We boil them to a high temperature, and they are going to vaporize and rise into the fractionating column. Now let me try to make an illustration of that. So this is the fractionating column. So it's going to have different outlets. So let's assume that there are 3 outlets. 1, 2, 3. So the mixture is going to be here. Let's say this mixture contains 3 gases or 3 liquids, A, B, and C. So let's assume that the boiling point of A is 20 degrees Celsius, the boiling point of B is 30 degrees Celsius, and of C is 40 degrees Celsius. They can be more varied than this. So let's now assume that for the fractionating column, each part is going to have different temperatures. So let's assume that the temperature here is let's say the temperature here is 35 degrees Celsius. The temperature here is 25 degrees Celsius, and the temperature here is 15 degrees Celsius. So what's going to happen? So what will happen will be that, let me make this 25, let me make this 20, and this should be okay, let's do it this way. So let's say the temperature here is 30, the temperature here is 20, and the temperature here is 10. Now, so what will now happen is that when they heat this mixture and it turns to gas and it turns to vapor, it's going to pass through here. Now when it reaches this particular part of the fractionating column, this is what we call the fractionating column. So when it reaches this particular part, the 3 of them are coming together like that. So they are going to heat them to a temperature where all of them will vaporize. So that temperature will be above all these values. So let's say they heat them to a temperature of 45 degrees Celsius. So what's going to happen when they reach this particular part? So when they reach this part, the fractionating column will check their temperatures. If it is 30, if you have a temperature higher than 30, you can pass through. But if you have a temperature that is 30 or less than 30, you can pass. So that means that when they reach this particular point, A will be able to pass, B will be able to pass, C will not be able to pass. Now what will now happen is that since A is having a temperature that is even lower than 30, that means it can keep going and enter the second part of the column. It can keep going and enter the second part of the column. So let's say this is the first part of the column, this is the second part of the column, and this is the third part of the column. So what will happen when they reach part 1? A will pass, B will stay there, but C will go back. Look at that. So it's only those that have the temperature of that particular point that will be able to remain at that point. So since B is staying here, what will now happen is that it will now pass through this particular point and come out. So that means that you have gotten your B, you have separated your B like that. Now what are you left with? C has returned to the container since it's having a temperature that is greater than 30, but A is having a temperature that is less than that 30, so A will now move to the second part. So since temperature of A is exactly 20, what will happen? A2 will now come out through this particular opening. So A will come out here and B will come out here, but C will remain inside this particular container. So I don't mean that we have, maybe there were 4 liquids, maybe we still have another liquid D whose boiling point is 10 degrees Celsius. So what will happen is that when they reach the first part, the temperature of A is 40, right? So A will not be able to pass through. Sorry, the temperature of C is 40, so C will not be able to pass through, so C will go back. We are now left with what? A, B and D. So what will happen is that A will go since it's having a lower temperature, D will also go since it's having a lower temperature, but B will pass out of the fractionating column. So A and D are still inside the fractionating column. So what will now happen when both of them are inside? So what will happen will be that A will now enter the second part together with D, because the temperature of D is what? 10 degrees Celsius. So when both of them enter this particular part, since the temperature of A is exactly 20, A will now come out. So A will come out of here, B is coming out of here. So we are now left with only what? Only D. So D will now proceed to the third part of the column. Now in the third part of the column, what's the temperature? 10 degrees Celsius, which is the same thing as the temperature of D. So that means that D will now come out of here. So that is how they are going to be separated. So even if they are more than that, you just have to divide the fractionating column into that equal amount of what you want to get. So that's how you are going to be doing it. So don't forget how the fractionating column is. The temperature decreases as you go higher into the fractionating column. So this is how we carry out the process of fractional distillation. So each distillate will come out at that point that has its own exact temperature. If it has a temperature that is higher than the temperature of that point, what will it do? It will go back. So because there is possibility that also, the temperature of this particular point is 20, so there is possibility that maybe B that has a temperature of 30 might enter this particular part. Since his own temperature is 30 and the temperature here is 20, what will happen? It will have to go back to this part again. So you have to go back to where the temperature is 30. So this thing is just like you are calling people. Maybe you invite them for something, then you are calling them. So what happens is that when they are calling them, they arrange their numbers 1, 2, 3, 4, 5. Then the contestants, they have to enter in this manner. They have to enter from the bottom. This is where we have the entrance. So when the contestants enter, number 5, we ask them, have you all been invited to this ceremony? Yes, we have been invited. Okay, if you are number 5, if you are number 1 to 5, please stay here. So all those people that won the let's say there is a particular lottery, so the people that won the lottery, they are numbered from 1 to 5. So if your number is number 6, that means you are not part of them, so they will send you away. So you are send them away. So you now ask people that are now from number 1 to number 5. So you now tell them, if you are number 5, stay here, I'm going to be the one to supervise you. But if your number is 1 to 4, then you can go. So that means that all those people 1, 2, 3 and 4, they will move to the second person. They will go into the second room. So if you are number 4, stay. If you are not number 4, go to the other room. That's where they are. So that means 1, 2 and 3, we proceed to the next room. So here 3 will stay, then 1 and 2 we proceed to the next room. Now let's assume that maybe this number 3 is a kind of person that is very forgetful. Those people that used to play a lot. So when they got here, they now said, if you are number 1, 2 and 3, please, if you are number 1 and 2, you can go. But if you are number 3, stay here. So number 3 did not hear. Then here now 1, 2 and 3 now enter. What do you think this person is going to say? This person is going to expect 2 people, then ask 1 to stay, tell the next person to go. So when the person now see the three of them, the person will now say that number 1 and 2, you are the ones that are supposed to pass through this place. So when the person sees number 3, what the person do? The person will just send number 3 back that, get out, Joe. You are not supposed to be here. You are supposed to be in the previous room that you just passed through. So that means that number 3 will now have to return to this room. So let's say that maybe there is number 6 with them that has been hiding and got to this particular point. What will number 2 do? Number 2 will send number 6 back to room 3. Number 3 will send him back to room 4, like that, until they later send him out completely. So that's what's going to happen. So this is exactly like the process of fractional distillation. It's actually very simple if we actually think of it. So that's how we carry it out. So they said the mixture vaporizes and enter the column. Those with higher boiling point condense more quickly and return to the mixture, while only the one with exact temperature passes through. So don't forget that. And when we are drawing this, you said when they come out, so anyone that comes out of here is coming out as a gas, but they will have to what? Condense it back to a liquid. So that is how we carry out distillation, fractional distillation, and we use it in separation of crude oil. So because crude oil is also a mixture, there are a lot of things inside crude oil. Now there is also the separation funnel method. This is actually very easy. So we use to separate liquids that do not mix. So let's say you have kerosene and you have water. They are not going to mix, so you can use separating funnel method. So what you just do is, since you know that kerosene will stay on top of water, you just look for a funnel. Then you put your mixture of kerosene and water inside. So you pour it inside here. Now if you pour it inside there, what you are going to notice is that since kerosene will be on top of water, this is what will happen. Let's say this is water in red, then kerosene will be on top of it. So let's say kerosene is the one in yellow. So this is how it's going to be. So then there's going to be a particular knob here that you can turn. So there's going to be a particular knob, so that when you open this knob, this one that is below will just pass through. So when you open the knob, the water will pass through. Then you can collect that water in a container. So your water is now going to be inside this particular container. So it's a very smart thing to do. So as the water is coming out, you just be looking at it that as everything come out. So when it remains only the kerosene, you just close this particular knob. So when it remains only the kerosene, you just close the knob. So the final situation will now be like this. So we are going to have our kerosene will remain inside here because you have blocked it. So kerosene will remain inside here while our water has gone to the bottom of the container at the bottom. So this is how we carry out the process of separating funnel. It's actually very easy, something that you can even do, but the thing is that it's somehow difficult because kerosene and water, their colors are almost the same. They are both colorless, so you might not be able to know that the water has gone out completely. But it's better when you want to use to separate liquids that their colors are different. But don't forget, you use to separate liquids that do not mix, immiscible liquids, unlike distillation that we use to separate miscible liquids, which is also the same thing in fractional distillation, also miscible liquids. Now we need to also talk about chromatography. Now when you are talking about chromatography is a little different than the other ones. So what's going to happen in chromatography is that you are going to have something like this. This is a paper. I want to explain paper chromatography. So in paper chromatography, you are going to have a paper. Now on that paper, you are going to drop that thing that you want to separate, that mixture that you want to separate. You drop it on the paper like this. So let's say the mixture is the one in blue. So we drop the mixture on the paper. Now after dropping it on the paper, what do? You look for a solvent. Look for a solvent, maybe like water. Let's assume that your solvent is water. So you are going to have this. So this is our solvent, which is water. Now you now put this paper, you now put it inside this water, but you make sure that this particular part does not touch the water. No, I just said solvent, so you can use any solvent that you like, that you think might be able to dissolve this particular mixture. Now, so let me draw a diagram of that. So these are our water, these are our paper. Now look at it. You see that our solvent, our mixture which we want to test, did not touch the water. So now what will now happen is that this water that we are having, the water that we are having is going to soak this paper. Our solvent will soak the paper and travel up the paper. It's something that is very common. They call this capillarity. Capillarity is when a liquid passes through a particular material that has been dipped into it and rises. So the liquid will just rise through this paper and go up. Now when the liquid is going, you know that it's also going to rise through this particular point that we drop our mixture. So that means that as it passes through this point that we have in our mixture, it's going to dissolve the mixture. Then it will now go with the mixture. It will dissolve it and carry it along. So this is just like moving river. What will happen when river is moving and you just throw maybe a plastic, you just throw your shoe on top of the water? What will happen? The river will carry your shoe away, right? So the river will carry your shoe away. So that's exactly what is happening here. So it will carry that mixture, it will carry it with it and dissolve it. Now if the mixture is made up of a lot of parts, if it is truly a mixture, what will now happen is that as the liquid is trying to pass through the mixture, it will dissolve it and separate it into parts. So it will now carry the parts separately. Just like you're having, let's still use the analogy of the river. You now throw two shoes into the river. Shoe one, let's say this is the first shoe and this is the second shoe. Note that you are throwing both of them at the same point, right? But both of them are not going to move with the same speed. What you will notice is that after some time, this one will be ahead and this one will be behind. Maybe this one is lighter and this one is heavier. So you just discover that this one is going to be ahead of this second one, so this second one will be behind. So that's exactly what's going to happen here. So that means that if this mixture, let's assume that mixture which is in blue is let's say these are a mixture in blue. Let's say it contains two parts. So these are the two parts. There is a part of it in yellow and there is a part of it in black. So that means that this is the original mixture, but when you separate it, it splits into yellow and black. So that's what will now happen when this our solvent passes through it, when it dissolves it. So when our solvent dissolves it and passes through it, it's going to split it into this yellow and black. So this yellow and black will now move at different speed. So what you now discover is that yellow, this one will not be here again. That yellow can now be around this point. Then the black will now be around this point. So what it simply means is that it is this blue that are separated into this yellow and black. So because of their different speed of movement, so that is what make them to now leave themselves behind, leave each other behind. No, just like when we throw in two shoes, the one that is heavier will stay behind, but the one that is lighter will be ahead. So that's exactly the same thing that is happening here. So it's going to be separated into the components. Then the one that can move fast will now be ahead while the one that cannot move very fast is going to be left behind. Now, another thing that we must know is that this paper, we call it the stationary medium. We call it the stationary medium because the paper is not moving, while the liquid, which is our solvent, we call it what? The traveling medium, or there's another way you can call it. If you don't want to call it the traveling medium, you can just call it the moving medium. So you can call it the moving medium. So we have the moving medium. So it's our moving medium that we carry the mixture. To carry this mixture and separate it, then one part will move faster than the other part. So these are stationary medium, which is our paper. These are moving medium, which is our solvent in this case, and the solvent is what? Water. So that is how we carry out the process of paper chromatography. There are also other processes that they are still chromatography, but this is the simplest example that we can have, which is what we can use to describe what we have here. So they said their solubility. Now another thing that we must know is that their solubility in the moving medium also depends. It also depends. So let's assume that this yellow one is more soluble than this black one. That means the yellow one will travel faster because it's more soluble. That means that the solvent will be able to carry it more than it will be able to carry this one, because this one is not soluble. So that's one thing you must know. The solubility is very important. The solubility is going to affect the speed of movement. It's going to affect their separation. Now, another things that are going to affect their separation is this adsorption. Is the adsorption. Now, what do you mean by adsorption? Adsorption is when something sticks to the surface of another thing. So, for example, when we drop this mixture on the paper, if the mixture stay on the paper, that means the mixture is adsorbed to the paper. Don't confuse it with absorb. Absorb is different. Absorption is different from adsorption. So adsorption means for something to stick to the surface of something. So which means that the one that is having a high adsorption to the surface of this paper will not be separated much. It won't travel fast. While the one that is having little adsorption will travel faster. Because the one that is having high adsorption, what it means is that the paper will hold it. So our solvent will not be able to carry it. Just think of it. So the paper is going to hold it. So the solvent will not be able to carry it away. But the one that is having low adsorption to the paper, that means that the paper will not hold it too much. Then the solvent will find it very easy to carry it. So which means that if a mixture is going to be separated, it is those ones that will move faster. Those ones that will move faster are those ones that they have little adsorption to the stationary medium and very high solubility in the moving medium. So that will be it. So if it has little adsorption, that means that the stationary medium will not hold it too much. And if it has very high solubility, that means that it will be easy for the moving medium to carry it, because nothing is holding it and it's even soluble in that moving medium. So that is how we carry out the process of paper chromatography. So please let us know this now, because it is actually very important. These are questions that they ask in WAEC. They are questions that they ask us in our external exam. So they move at different speeds and separate into spots on the stationary medium. So this case, the case that we just explained, is the paper chromatography. So another example is the gas chromatography, which also uses almost the same principle. So chromatography is used in medical diagnosis to check urine content. So you want to check those compounds that are present inside that particular urine. You can use chromatography to do that. Then you also use in health departments to check required compounds in drugs. So there are some drugs that are going to contain more than the amount of some compound that is supposed to contain. So they can also use the principle of chromatography to catch those people that are trying to do that.